Welcome back to class. So we are going to look at internal landforming processes. This is the first Form 2 geography topic. And so before we dive in, we would want to know how we are going to manage this topic. It's quite lengthy. And so remember, you can switch to subtopics. Just look at the bottom of your YouTube progress bar, and then you can be able to switch whether you are not interested with folding and you just want to look at something different, folding. You can just switch, click to the next subtopic. Yeah, and with that said, let's start off. Yeah, so that's our topic today, and of course we have objectives, and let's go through them in a few. So this topic, it's like a very large topic which we can be subdivided to such independent topics. And so all in all, at the end of this topic, we should be able to define earth movements, explain the causes of horizontal and vertical earth movements, explain the theories of continental drift and plate tectonics, define folding, faulting, volcanicity, and earthquakes, explain the process of folding, faulting, and volcanicity, describe types of faults, and forms of volcanicity, explain features that result from faulting, folding, and volcanicity. And we're also going to explore the causes of earthquakes, describe how earthquakes are measured, and also account for the wild distribution of earthquake zones, fault mountain systems, and features due to faulting and volcanicity. And finally, we are going to explain the significance of the resultant features of faulting, volcanicity, and effects of earthquakes. So as you've seen, there's a lot of explanation, and so since this class is meant for revision or more of an introduction a bit for someone who's headed to this class, let's say Form 1 headed to Form 2, and I would like to know what it is. We're going to keep this quite easy and simple. So let's start. So we are first going to define what earth movements is. Earth movements, these are processes operating in the interior of the earth, resulting in the formation of natural physical features or landforms. They are caused by earth movements. Formation of landforms by internal landforming processes is determined by the nature and age of earth materials, the type of movement involved, the intensity and scale of the movement. So we are going to look at the types, rather the forms of earth movement. So we have the crustal earth movements. This is the displacement of the earth's crustal rocks. They are brought about by tectonic forces which originate and operate in the interior of the earth. These are tension forces, compression forces, shear forces, and gravitational forces. So earth movements, there are two types, and we have the horizontal or lateral or orogenic movements, and we have the vertical movements. So we are going to look at the horizontal movements. So these are movements which act along a horizontal plane within the crust of rock. They are caused by tensional and compressional and shear forces. The effects, they cause strain and stretching of crustal rocks due to stretching caused by tensional forces, which causes formation of cracks or faults. Squeezing and shortening of crustal by compression of forces, rocks which cause them which also cause the formation of faults. And thirdly, so we have crustal rocks to shear by slipping past each other or by dividing into layers. which is a responsibility of the shear forces. So let's look at the results of horizontal earth movements. So we have faults, we have rift valleys, we have fault mountains, we have escarpments, we have basins, we have tilt blocks, and we have the block mountains. Now we're going to look at the vertical earth movements. Movements which occur along the Earth's radius or towards the Earth's surface or towards its center. They cause sinking, downwarping, or pulling of crustal rocks downwards. Also cause upwarping or pushing of crustal rocks upwards. They cause tilting of crustal rocks or shearing in vertical direction due to greater uplift on one side. What are the results of vertical earth movements? We have raised cliffs, we have tilt blocks, we have rift valleys, we have escarpments, we have plateaus, and we also have basins. Causes of earth movements, they should be A, convection occurrence in the mantle. B, isostatic adjustment. This is the rising of continental masses to restore the upset state of balance between CL and SIMA layers. So you can look, I've linked the video on discussing the structure of the earth, which will discuss into detail what the CL and the SIMA is. So isostasy is the state of balance between the CL and SIMA layers. It can be disturbed by erosion on continents and melting of continental ice sheets. So, theories of the origins. And the first theory we are going to discuss is the theory of continental drift. It states that the Earth was a single cyclic landmass called Pangaea, surrounded by the huge ocean called Thalassa, whose floor was a mass of SIMA. And so Pangaea broke into two parts called Laurasia, which lay around the equator, and the Gondwanaland, which lay around South Pole, which was separated by a narrow ocean called Tethys. So the Laurasian broke into Laurentian Shield and Phenoscadia and moved northwards to their present positions. Gondwanaland broke into Africa, Australia, South America, and Antarctica and India subcontinents. Let's see the evidence that support this theory. We have the fitting of western coast of Africa and South America into a jigsaw, discovery of coal 40 degrees north and 50 degrees north, which was formed by burying of tropical vegetation, considerable displacement of rocks along some faults. Cape and Buenos Aires fault resemble one another by having east-west trend. The Red Sea shores show evidence of having undergone lateral displacement, an indication that it was formed by movement of the earth crust. So, evidence of ancient glaciation to the south of equator in Africa, in Madagascar and India, where there is presence of ancient glacial deposits, suggesting these areas were once around South Pole. We also have another theory called the tectonics theory. It states that the earth crust is made of blocks called plates. We have the 7 large ones and the small ones. You can look at them. These plates are two types: the tectonic and the oceanic plates, which form major areas of the ocean floor, including coastal lowland. Continental plates, which form the bulk of the continental landmass. And so they say the plates float on molten mantle layer called a asthenosphere. The plates move relative to each other due to convection occurrence in the mantle. They move away from each other, forming extension or constructive boundary called so because magma fills the space between. There's more to it. They move towards each other, forming compression or destructive boundary, called so because materials between are crushed. The movements of those two types of plates have the following effects. One, there is subduction and the ocean floor is pulled inwards, forming a trench. Subduction is the passing of edge of one plate beneath the edge of another. Sediments on the seafloor in the region of subduction are compressed to form fold mountains. When an oceanic plate meets a continental plate, the edge of the oceanic plate slides beneath the continental plate in a movement called subduction. So sediments on the seafloor in the region of subduction are compressed to form fold mountains. That's something I'm just repeating so that we get the flow. So, significance of plate movements. 1. Are sources of earthquakes and volcanicity. 2. Causes formation of landforms such as fold, mountains, and ocean trenches. Spectacular landscapes formed are a tourist attraction. And finally, we have eruption of magma can result in formation of valuable minerals. And so we are going to take a break. It has been a long stretch, and then we'll be back with the folding. We are going to define it and the processes of folding. So welcome back. We'll proceed. So folding. This is a process in which crustal rocks are distorted by compressional forces by being caused to bend upwards and downwards. So parts of a fold. You have the anticline, the syncline, crest, trough, the limb, and the axis, as illustrated in the figure below. So we also have the types of folds. These are parts of a fold. So we're going to look at the types of folds. We have simple symmetrical folds. We have asymmetrical folds. We have overfolds. We have isoclinal folds. We have recurrent folds. We have nape or overthrust fold. We also have the anticlinorium and cyclinorium complex. And so we intend to just use this class to refresh. That's why we're not getting into the details, and we're not looking at so many diagrams of the same. So take your time to can pause somewhere and try to recall the image and sketch the diagrams on your notebook. And so we're going to look at the resultant features due to folding. One, we have fold mountains, and we're going to look at their distribution. So world's highest and most impressive mountains are the most conspicuous features of folding. And we have the Himalayas in Asia, the Andes in Peru, we have the Alps in South Central Europe, we have the Rockies in West North America, we also have the Atlas in Northwest Africa. Let's look at the theories. Remember, theories are just suggestions trying to explain a certain phenomenon. So we are going to look at the theories of the origin of fold mountains. And on this segment, we have the contraction theory. They suggest that during the Earth's formation, surface rock cooled faster and recoiled to form fold mountains. The convectional currents theory suggests that horizontal convectional currents in the mantle exerted frictional pull on crustal rocks. Continental crusts were pulled towards each other. Sediments between them were squeezed into folds. There is more. The continental drift theory suggests that during the break of Gondwanaland, India drifted northwards and collided with Eurasia. So sediments between were squeezed to form fold mountains, the Himalayas and Everest. We have plate tectonics theory, which suggests that when an oceanic plate meets another, or it meets a continental plate, the sediments under the sea are compressed to form fold mountains. So when two continental plates meet, the sea layer is compressed to form fold mountains, and that's all. So the resultant feature of folding that we have been discussing is one, fold mountains. We're going to look at the second one, escarpments. So an escarpment is a relatively continuous line of steep slopes facing the same direction. It is formed, one compression force causes folding, resulting in one step limb of the anticline which forms the escarpment. We also have another feature, depressions. We have ridges and valleys. So when folding occurs, anticlines form uplands, the hills, while the synclines form the valleys. We have rolling plains, which are formed when plains are acted upon by weak compression forces, resulting into gently sloping anticlines and very wide synclines. We also have intermontane plateaus, which is a fairly level land between mountains. And finally, probably we have the intermontane basin, and these form the resultant features due to folding. And so we are going, you can get back, you can review what we just looked at. We can do that in a very short while. Just name the resultant features due to folding. We have the fold mountains, and we have the theories that try to explain how they came to be. Number 2, we have the escarpments. Number 3, we have the depressions. Number 4, we have the ridges and valleys. Number 5, we have the rolling plains. Number 6, we have intermontane plateaus. Number 7, we have intermontane basins. And we are now going to look at the significance of folding. 1, to human activities, or whether they have some economic significance. So of course, we have we have both advantages and disadvantages. So I'm just going to look at the first two, and then you can pause the video and remind yourself of the rest. So 1, fold mountains are tourist attractions which brings foreign exchange. Fold mountains are water catchment areas and sources of rivers. And 3, some fold mountains have valuable mineral deposits such as coal and petroleum. Let's look at some disadvantages. So, fold mountains on the path of rain winds cause the leeward slopes to receive less rainfall. 2, fold mountains discourage settlement due to cold temperatures and rugged terrain. And finally, we can suggest that fold mountains can lead to barring of minerals, which makes it economically hard to extract them. We are going to look at the significance to the physical environment. Number 1, folding can result in submerged coastal zones, which are used as harbors. They can lead to metamorphism of rocks, changing their original state and making them more resistant to erosion. Point to note, I hope you remember how metamorphic rocks are formed. If you can't, we're going to link a video. We are going to link the class on on your top right. So let's look at faulting. Faulting is the cracking or fracturing of the brittle crust or rocks due to tectonic forces. So faults are fractures or cracks that develop in the crust. Causes of faulting to occur are 1, When tensional forces cause crust rocks to stretch and fracture at the region of maximum tension. So when compression causes squeezing of crustal rocks to fracture at the areas where they intensely squeezed. And 3 can be occurred due when the vertical movements exert pressure on the rocks, leading to fracturing. So we're going to look at the diagram, which contains the parts of a fault. Just like we looked at the parts of a fault, you can see the head, the heave, the fault line, the down throw, the up throw, and onward we just look at the types of faults. So we are going to, with a visual aid, the diagrams, I hope it will be easy for us to grasp as we move on. So we have normal faults. You can feel free to pause the video and review. We have reverse faults. We have shear or tear faults. We have thrust faults. We have anticlinal faults. And we are now going to look at the features resulting from faulting. These are escarpments, which are steep lines of slopes formed by vertical movements of earth along a fault. And so these are the exposed parts of the fault plane. If you can review the parts of a fault, you can be able to marry that. Number 2, we have fault steps. This is land resembling the staircase or steps of a house with a series of fault scarps at different levels. We have fault blocks, also known as host mountains, blocks of land raised above the surrounding land. So how they are formed: where tectonic forces cause faulting and land on one side of the fault get raised or sink along the fault lines, where block mountains of land bordered by normal faults which are almost parallel to each other sink, leaving the middle block standing. So those are 2 ways they can be formed. The next feature we're going to look at is tilt blocks. Occurs when the fault block have greater uplift on one side, and as a result they are not flat at the top but tilted. And finally, we can look at the Rift Valley, which is a long narrow trough with steep escarpments on both sides. There are some theories that explain the formation of the Rift Valley. And the first one, we have the tensional theory, which suggests that rocks are subjected to tensional forces. Normal faults which are almost parallel develop. One block slides downwards, forming the Rift Valley. We have the compressional theory. Rocks are subjected to compressional forces. Reverse faults which are almost parallel develop. The side blocks are pushed over the middle block. Overhanging blocks are worn out by denudation to form the escarpment. We have one more. The anticlinal theory. It suggests the Rift Valley was formed by anticlinal arcing. I hope we can recall the types of faults. So, upward forces pushed sedimentary rock strata upward. The rock layers bent into a big arc. So, and then a big crack developed at the crest due to the tension forming the Rift Valley. And we have the Great Rift Valley, which is the world's biggest Rift Valley. It starts in Syria and ends in Mozambique. It actually passes through Kenya. So you can look at the parts, how it's divided, the parts it's divided into. And then we're going to to discuss, maybe something interesting. So on the Rift Valley, there are some lakes, and most of them are salty. So these usually are quite highly examinable question. And so I'm going to briefly try to give you some points. So why most Rift Valley lakes are salty? One, they lack outlets to drain away salts contained in them. Two, lack of enough water to dilute salinity due to little rainfall and lack of rivers flowing in them. High rates of evaporation causing increased accumulation of salts, and the lake's water being in contact with rocks with mineral salts which directly dissolves. And maybe one more, washing into the lake of mineral rich soils by surface runoff. But we have a lake, some lakes which are as well on the base of the Rift Valley, but they are fresh. For example, is Lake Naivasha. So why is it fresh? It has underground drainage to the Indian Ocean. There is inflow of fresh water from rivers and rain, and the latest volcanic eruption covered the bedrock with lava. So it is also located in a region of high rainfall inputs. So which are the major faulted areas of the world? We have the Great Rift Valley from Syria to Mozambique through Kenya. We have the Northern England and the Great Glen Fault of Scotland. We have the Central Massif of Europe. We have the Middle Rhine Rift Valley region. So what's the significance of faulting to human activities? And of course, we're going to look at both the positive and the negative. And as agreed, I'll just give you 2 or 3. Then you're going to review the rest, both from these notes and from your notes. 1. The Rift Valley lakes are important for fishing, irrigation, and domestic use. 2. The Rift Valley and associated features are a tourist attraction which earns foreign exchange. And 3. Hot springs and geysers formed during faulting can be harnessed for geothermal power. So let's look at the negative ones. Faulting disrupts transport and communication by disjointing land. 2. Faulting may lead to loss of life and property by causing land to sink. And 3. Faulting may cause a river to disappear or change its course and flow along the fault line. So we've covered quite a bit, and here we are going to proceed to our second break. And so all these notes, they are available on your Google Play Store. Just look for the Geography app by Revision KE. The icon is brown, as you can see on your screen, so you can check it out. And as we proceed for the break, I'm going to give you a minute or two to look at the reasons I'd given you why most Rift Valley lakes are salty. So you can pause the video to review that. And you can also look at why Lake Naivasha is a freshwater, happens to be a freshwater lake. Yeah, so I hope that was quite a good break to refresh. So we are going to proceed with volcanicity. So, what is volcanicity? It is a process in which solid, liquid, or gaseous materials are forced out of the interior of the Earth into the Earth crust or onto the Earth's surface. These materials are magma, lava, gases, dust, ash, and cinder. So, what is volcanicity? This refers to the process where igneous materials reach the surface of the Earth. It is also referred to as volcanic eruption. So, what are the causes of volcanicity? We have magma under high temperature and pressure moving through lines of weakness or faults. 2. When tectonic plates move away from each other and boundaries give way to magma. 3. Underground water coming into contact with hot materials, hence changing its gaseous form. So, what are the types of volcanicity? We have intrusive, in which materials intrude crustal rocks and don't reach the Earth's surface. And then we also have the extrusive, so plutonic. You can recall from our topic, our previous topic in Form 1, linked above, in which materials reach the Earth's surface. Lava is the molten material after it reaches the surface. So there's quite a bit where we are going to look at the intrusive features resulting from volcanicity. And here we're going to just pause. I'll allow you to pause the video and try sketch that diagram and name as many parts as you can. So here it is. Let's proceed. And so we are going to look at, I allowed you time to pause and review the intrusive features. I hope you're able to note them down. So I'm going just to mention them as and summarize them as we proceed. So the laccolith, which you can see here, it's a mushroom. I hope you can see it. It's a mushroom-shaped igneous intrusion lying between bending planes of a country rock. We have the seal, which is an igneous intrusion which lies along a bending plane of rock strata. We have the dike, a wall-like igneous intrusion which lies across the bending plane of rock strata. We have the batholiths, the lapoliths. We have the what do we have here? We have the Vulcanicity. So I'll head back to the image so that you can try map that out, map the information we've discussed onto the image. And so we are now going to look at the extrusive features. These are formed when magma reaches the Earth's surface through vents or fissures. So we have volcanoes. A volcano is a cone-shaped hill formed when volcanic materials flow out and accumulate around the vent. So volcanoes are classified into three groups. We have the active ones, which are known to have erupted in recent times. We have the dormant volcanoes, not known to have erupted in the recent past but show signs. And then we have the extinct volcanoes like Mount Kenya, which have not shown signs of possible future eruptions. Another type of volcano we have the acidic lava domes, which is a steep dome-shaped volcanic hill made of acidic lava. And we have the process of forming that. And here is the image. So it's characteristic, it's dome-shaped, has steep slopes, made of acidic lava, has lava layers, has a narrow base. Second, we're going to look at the basic. I hope you'll be able to note the difference. The basic dome or shield domes is a low-lying volcanic hill made of basic lava. And here it is dome-shaped, has gentle slopes, made of basic lava, has lava layers, and has a broad base. We have a ash. Number 3, ash and cedar cones. These are types of volcanoes. A volcano built from ash and cinder or small fragments of lava. And here it is made of pyroclasts. It is asymmetrical about the axis. It's cone-shaped, has smooth slopes, has steep windward slope and gentle leeward slope. We have the composite or complex volcanoes, which is a volcano made of alternating layers of lava and pyroclasts and conelets. So this one we can take some time to discuss it. So the first eruption throws out pyroclasts. The viscous lava flows out and solidifies on them. Eruption occurs later, blowing the rocks, sealing the vent. So the pieces of rock settle on the earlier solidified lava. Another mass of lava flows out and spreads over pyroclast and solidifies. This process is repeated, causing the volcano to build upwards. And that's why we can see it has many layers. Probably a fine one, we have the plug dome, which is a column of very viscous lava which sticks above the ground. This is how it looks. And we have the volcanic plug, which is a stump of rock formed when magma, which solidifies inside a vent plug, is exposed by denudation. Here is a diagram of the same. We have lava plains and plateaus, as illustrated in the figure. They are caused by fissure eruption, where magma of low viscosity comes out of the ground through a fissure. It flows for a long distance before cooling and solidifying, filling depressions and valleys, forming a plain. So when an eruption occurs later, lava flows out through the lines of weakness on crustal rock and solidifies lava. The new lava spreads on top of the old lava, forming a new layer. This is repeated and a plateau is formed. We can look at that image again. So another type of volcano, we have a craters, which is a funnel-shaped depression found on top of a volcano. And there are quite some interesting modes of formation, which you can look at. One, we have cooling and contraction of magma. 2, we have explosion. 3, we have falling of a meteorite. We have another type called a caldera, which is a very large basin-shaped depression on the summit of a volcano. It can be formed due to a violent explosion. Illustrated. We also have can be formed through block subsidence, and finally can be formed through outward collapsing. We also have fumaroles. These are gases. The gases come from chemical reaction in crustal rocks when heated by magma or when minerals in rocks come into contact with hot air and steam underground. They are of 2 types, mofettes and solfatara. We also have hot springs and geysers. Hot springs is a place where hot water is emitted from the ground quietly. We have these are the shores of Lake Magadi and Bugori in Kenya. So a geyser is a jet of water and steam which are violently ejected from the ground. This is seen in Olkaria and the western shores of Bogoria. And here is some difference between the hot springs. So in a hot spring, water comes out quietly, while in a geyser, water and steam come out violently. So you see, in a hot spring, only water comes out. In a geyser, water is accompanied by steam. Yeah, and hot spring water may just be warm, while in geysers, water is very hot. There is more to the types of volcanoes. We have pools of boiling water, and then we're going to look at some world distributions of volcanoes before we look at the significance. So these could be regions of faulting, such as the Great Rift Valley of East Africa. We have the Mid-Atlantic Ocean Ridge. We have the western coast of America. And we have zones of recent mountain building, such as the Fall Mountains of Southeast Asia. So let's look at the positive significance or advantages of volcanicity. So volcanic rocks weather to form fertile agricultural productive soils, such as basalt. So geysers are sources of geothermal electricity. We have that plant in Olkaria. Hot springs water is pumped into houses for heating during winter. It is in Iceland. And finally, volcanic features are a historic attraction. It's like hot spring geysers and the snow-capped Mount Kenya. So let's see whether we can look at some few negative effects. So volcanic eruptions cause loss of life and destruction of property. So volcanic mountains are a barrier to transport and communication. And volcanic mountains on the path of rain winds cause leeward slopes to receive little rainfall by preventing rain-bearing winds from reaching there. And finally, volcanic eruptions cause environmental pollution from dust, ash, and sulfur dioxide. So, questions on significance of a certain concept, they are actually application questions. So you just look at how could it be of a positive effect or how could it be of a negative effect. So let's proceed. We are going to look at earthquakes. We are going to define them. We are going to discuss shortly how to measure and how they are measured. We are going to look at the distribution and also the effects of earthquakes. So, an earthquake is a sudden and rapid movement of the Earth's crust caused by shock waves. So, an earthquake originates from a point known as a seismic focus. That's the part of the Earth vertically above the seismic focus where the shock waves are first experienced is called the epicenter. We have natural causes of earthquakes. These could be tectonic movements, could be due to volcanicity when magma movement displaces rocks suddenly, shaking and shattering them. So we also have gravitative force when crustal rocks collapse into cauldron due to gravity. And we also have some human causes, such as exploding nuclear bombs underground, which cause shock waves which spread outward and are felt in the neighboring regions. So we have explosion of explosive used in mining and quarrying, which cause vibrations to be felt in the neighborhood. See, when large reservoirs are constructed and the heavy weight of water reactivates, dormant faults causing tremors. How do we measure? How is earthquakes measured? So earthquakes are measured by the intensity and the magnitude. I'm just giving you the details you need to remember. And It's recorded in a graph like a record called a seismogram. Yeah, you can look at that. So the intensity, it's measured on a Mercalli scale, while the magnitude is measured in a Richter scale. I think these are very common questions. You can agree with me. So earthquakes, what's its world's distribution? So it's, as mentioned earlier, it's within zones of major faulting, areas of volcanicity, or along boundaries of tectonic plates. So you can find out how they're distributed on a map on the world zone, or you can be able to chart that out with this information. So, what are the effects of earthquakes? They can cause loss of life and property when building collapse, burying people. Uh, they disrupt transport and communication by vertically displacing land, which disconnects pipes, electricity lines, roads, and railways. They also cause landslides, which also cause loss of life and property. And so, up to this point, I think we are not expecting to see something good from earthquakes. And that actually marks the end of our very long topic. So, you can make use of the chapters or the subtitles to review a section here or a section there. And so, till next time, we can meet. For more details, you can remember to download the geography app. This is the icon, it's available on Play Store, and the link is linked at the description section of this recorded class. So, till next time, goodbye.